Hi and welcome to Bytes and Bits. In one of my previous videos I showed you an overview of my RGB LED Lightbox project, and that's the thing just sitting here behind me. So in this video I'm going to talk you through how you can actually make one for yourself, so how it's constructed, all the bits you need, and then how to put it together. So let's get straight into that. Now, if you haven't seen the overview video, then please do have a look at that for full details of what this project can do. But in essence, we're simply building a large-scale 16 by 16 pixel display using individually addressable RGB LEDs for each of the picture elements. So this means that we can use it as a simple light box, where we can just simply vary the brightness and colour, but then also as a programmable light show to add a bit more excitement to our room. Now the project is based around a Raspberry Pi Pico W connected to a string of 256 NeoPixel LEDs. So these NeoPixels use the WS2812 driver chip teamed with a 50050 RGB LED to create a mini network of individually addressable 24-bit colour lights. Now, I've also added a few buttons to allow us to navigate the various display options, and a microphone to allow the system to listen to the surrounding sound. But other than a 5-volt power supply, that's the full circuit. So on screen at the moment, you'll see the full circuit diagram, which shows which I/O pins I've used for my coding. Now, if you're building your own, please try to stick to these pins, otherwise you're going to need to modify my code to suit your circuit. Now, all of these circuit diagrams, the code, and all of the 3D printing files that you'll see later are all available through the main project page on my bytesandbits.co.uk website, and I'll drop a link to that in the video description. Now, for the moment, I've built this circuit up on some matrix board so I can get things up and running more easily. And now I will be using this project to show you how to make your own PCBs, and also how to test some professional PCB and 3D printing services. So please do watch out for those videos. Now again, if you're building one of these circuits up yourself, everything is finalized, so the actual circuit isn't going to change. So please feel free to just go ahead and build yours. Now, the only part that you need to pay attention to when you're buying in your parts is the power supply. So this needs to be at least a 5 amp 5-volt power supply. And really that's because if all of these LEDs are turned on at full brightness, then the full network can pull up to about 4 amps. So just make sure that your supply is working well within its capabilities. And indeed, for my project, I've actually bought a 10 amp unit for this project, just in case I decide to make the LED network even bigger. So that's the basic design then for our light box. So the actual parts which I'm going to use for this then, for the base plate I'm going to use a cut MDF sheet, and that's where we're going to stick everything else to then. The mirrored background is going to be a mirrored perspex sheet, so I can buy that then from one of these sheet perspex suppliers. And again, all of the parts and details and the design files for any of the 3D printed parts then I will put onto the main project page in my bytesandbits.co.uk website, and you get a link for that then in the video description down below. The LEDs then that are going to go onto this mirrored sheet then, I'm using these stripped NeoPixel ones. So again, these come on a sort of a large roll, and I'm using the 60 NeoPixels per meter real version. So these then I will cut into strips of 16, and these will in effect be glued, or they come with a sticky surface on the back of them. So those will be stuck down onto this mirrored sheet, and I will then create there'll be 16 rows of 16 to give us our 256 pixels in this display. So in front of that then we will need to create the little cells. So I'm using these 3D printed parts, and basically these will then slot together to generate, I just put one together very quickly, So these will slot together then, as you can see, and these will create the little cells which will sit around each of these neopixels. So that will then create a sheet across here to give us our grid. In front of that then, I'm going to be using a diffuser. This diffuser is going to be a semi-transparent Perspex sheet. So again, if I pull the backing sheet off there a bit, you can see that we then have the semi-transparent Perspex sheet. And that will act then, of course, to diffuse that light a wee bit to give us our more even colour for our pixels. So this sheet, of course, is being held above the neopixel array, and for that we're going to need to create some sort of framework. So again, I've 3D printed the side frames for this. So these will then glue onto the base frame. The mirrored surface will fit into this recess here. There'll be a gap then left here for the neopixel array, and then there's a slot on the front here where the Perspex sheet, the Perspex diffuser then will slot into that, and that will then be held in front to give us our Lightbox. So again, we've got the various parts for that, and again, as I say, all the 3D files for these will be in on the project page. To drive the pixels then, we will need a circuit board. Again, in this particular video, I'm just going to be putting the Lightbox together, and we'll see it working. So more as a DIY project. The actual construction and design of all the circuit boards, I'll go into that in a lot more detail in some subsequent videos where we'll go through the actual software and everything in those in a bit more detail. But this circuit then, I've just built it up at the moment on this little bit of prototyping board. So we've got the wiring in the back there. And all we've got then is a Raspberry Pi Pico microcontroller, which is the brains of the system, and that's going to do all the driving of our neopixels and our various displays. I have built in a microphone so that we can then expand this out to listen to sound in the area, and then work in some sort of like spectrum analyzer display to sort of create animations on the pixels to basically sort of in sequence with any sound that it hears. There's a power supply input here, various connections then off to run wires up into the pixel array. And then I've set up some buttons and some feedback LEDs so that we have some sort of on-board control for this device. These will sort of act as menu buttons and select buttons and so on. But of course, we're also going to, I'm using here the Wi-Fi enabled version of the Pi Pico. So we will create a web control panel. So we'll be able to dial up using our browser on our phone, dial up into the device and control it through that as well. So that's going to, in effect, be mounted somewhere down here on the base plate, and that will then feed up into that. And again, I'm going to keep mine sort of visual so we can actually see that there is a circuit board there, just as part of my overall design. We could, of course, mount this. We could, of course, cut the base sheet off here and mount this somewhere behind, but I'm having mine on display. Powering it then. Because we've got 256 pixels on here, there is a possibility, if we turn everything on full, that could draw up to about 4 or 4 and a bit amps. So we have got quite a bit of a requirement for current in here. So I'm using a 5-volt power supply here. The one I'm using is rated at 10 amps. So that gives me plenty of leeway then for using the 4 amps on here. If we do want to go with a smaller power supply, we will have to sort of modify our software to make sure that we don't put all of the pixels on full in one go. So I would advise that you do get at least a 5 amp 5-volt power supply, and that just makes sure that if we do end up with everything on, your power supply isn't going to get overloaded. Not that it will actually damage the power supply, because all power supplies will be overload protected, but it just means that you are then able to run whatever animations you want to. So those are all the parts then that we need for this. And again, where to get hold of them, all the design files, I will put that then on my main project page, so do go and visit that. So what we need to do now then is to actually build it up. So let's get that put together. So probably the longest part of the project is actually printing out the 3D parts. There are quite a few to make, so it is going to take a few hours to get that all done. But just let your printer run through and you'll get there. To build up the pixel cells, as I showed, we're going to use these 3D printed pieces, and these will form the actual cells that will contain the light for each of the individual pixels. And they're built up from two different types of strips. So these again are 3D printed from my designs. And again, all the designs will of course be on the project page. But we have here two sets. One set has a series of castellations down on the base of them. So that will sit with the castellations down on the board. And there to allow, if I can get over here, there to allow the LED strips to sit on there. So these will sit flush with the base plate, but going over the top of the LED strips. That's what these little castellations are for. So with the LED strips being horizontal, these ones will then be my vertical divider strips. We then have the horizontal divider strips, which are just cut here. And again, you can see that these slots then are halfway along. So these will then, of course, slot together to give us that LED to contain each individual LED. Now, because my 3D printer isn't big enough to print the full 16 by 16 dividers, I've had to divide them, to split them up into two parts. So these will in effect join together like that, and that will then create my 16 pixels going across. Now, I did want this to then interlock together. So I didn't want to have sort of four separate blocks of 8 by 8. So I actually wanted them to actually integrate together. And these are then designed to do that. If I bring in the main sort of array, the way I've designed these then is that by staggering the ends of each of these rows, and you can see they're staggered both on the horizontal and the vertical side here. What that means is that then when we get to so there's an 8 by 8 grid here, an 8 by 8 grid, 8 by 8 grid. So one more 8 by 8 grid to put into here. What will happen is as we build this up, the actual pieces will interlock together and then form a full 16 by 16 grid. So I'm not going to have to stick them all down separately, line them all up. We will have a single 16 by 16 grid, which will then quite easily we can move it around. It will then just fit over the top of our LED pixels. The little bits where they join together, it's not so important that they line up exactly. They're pretty good, but it will just give us those nice little cells to get it together. So let me finish off this last little bit in here, and I'll show you the full LED array. With the complete, if we try it on one of the Perspex sheets, you'll see that the ends overlap. So we do need to now trim these down. So with it being only 1mm thick, you can just simply use a pair of sharp scissors, trim down the ends. And once we've completed that, you'll see that it now fits nicely inside our space with some area around the edges for our wiring. Next, we need to build up the frame. So the best way to do this is to assemble all the pieces. So I'm going to put the mirrored sheet in. I'm then going to fit the side panels around that, and then put the diffuser in as well, slotting it into the side panels as well. And this then gives me the complete unit, which will form the Lightbox. I can then position that on my backplate, mark the position of it, and then I'm going to use my glue gun to put a line of glue around the edge. And what I'm trying to do here is I'm trying to stick down the 3D printed edge pieces and not the actual mirrored area itself. So once I've glued all that in place, we should now have our assembly. And once that glue's all hardened then, you should be able to slide out the diffuser plate. That should just slide straight out. And I can take out then the mirrored surface as well. And just to note, I did drill a hole for access for our wiring so that we can feed those wires through to the actual RGB LED strips. So the next step is to fit the LEDs. I've created a little template that you can print out, and that will help you mark out where the top and bottom extents of the grid are, together with each of the center lines for the LEDs, so you can stick them on. So on one axis you'll need to rule in all of those plus the center lines, and then on the horizontal then you'll just need to mark the total extents of the grid. So you should end up with an outer box, which will be the external dimensions of the whole grid, and then all the center lines for the LED strips. So all that's left now is to actually stick the LEDs onto the mirror. Now there are some very important points you need to make sure of as you stick these on. If you have a close look at the strips, you'll find that there is a data direction. And these neopixels, they work, each pixel transfers data to the next pixel. So we feed data in at one end, and that data is then daisy chained along them in this direction of the data. So what we're doing here is we're creating rows of 16 pixels. So once the data reaches the end of one row, it then has to feed into the data input of the next row. So what we need to do is make sure that we have a sort of a backwards and forwards of data transfer as we go up from the bottom row. Remember, we're feeding the data in the very bottom left corner of this array. So it will transfer to the right along the bottom row, then it needs to feed into the right hand end of the second row up, and it will then transfer along to the left, and so on all the way up to the top row. So you do need to make sure that you align your data directions so that we get that backwards and forwards transfer across each row as we move up the LED array. So making sure you get everything in the right direction, just simply then stick down all of the LED strips and you'll end up with your full 16 by 16 array. And if you try your little divider box over the top of it, you should find that everything aligns really nicely. So all we need to do now is wire this thing up. So on the wiring side, there really are two halves to the circuit. There's the power side and the signal side. So on the power side, it's designed to split the 16 rows up into 4 blocks of 4 rows. And that's really to reduce the total current coming up any one wire. If we have one wire feeding up from our circuit board, it will obviously have to carry the full current, which could be up to 4 amps. And I'm using quite thin signal wire here, so that could overload the wire itself. So bringing 4 wires up to power each of these quarters separately just means that each power line is only going to have to carry at most about 1 amp, and that should be fine. Now as you are wiring them up, obviously we've had to flip these strips over to get the data flowing in the right direction. So do make sure that you connect the 5 volts and the 0 volts together correctly for each of the 4 blocks. Now, and on these small inter-row blocks, I'm using some solid wire here. And one thing I found is the castellations on the divider strips, I've allowed 1mm on there. If you do catch it on the insulation, that the insulation can be a little bit thicker than that sometimes, especially if the wires aren't quite level. So I'm using I'm stripping the wires back slightly longer so that the actual bare uninsulated wire is the one which is actually going to be going underneath the divider strip. So again, because it's quite close to the edge there, that doesn't cause a problem with it bending and touching. So just be aware that that is something which I found helps keep the divider strips nice and flush against the mirrored surface. So again, once you've wired those up, again, we then need some flying leads coming down from each of the 4 quarters, and they'll eventually go out through the hole in the bottom of the frame and out to the circuit board. The signal side of it then, again, the very first signal has to come up from the circuit board, and that arrives in the bottom left corner of our array, and that then feeds along the bottom then to the right. So basically at the end of each row we have the data coming out, and that then needs to be fed into the row above it, and so on, going back in this left to right format all the way up until we get to the top row. So that should be the wiring then. Let's go and see then. We'll do some tests now. We'll actually plug it up into the circuit board before we install it into the actual frame and see if we've got everything working, just to make sure that we've got everything wired up correctly and all of the LEDs are operational. So everything's all set up and ready to go. So if I just start off a test bit of software, we can see there that we're getting the LEDs all showing up. This test software just turns all of the LEDs on to different random colors every second or so. I do apologize. The LEDs are really creating havoc with my camera. It's picking up the sort of the refresh rate on them there. But you can see that everything is working. So let's try adding on the divider sheet and the front diffuser panel and see what that looks like. So making sure that we get the cancellations going over the top of the wires and any PCB tracks, and then giving good press down on the diffuser panel just to get everything lined up. And then if we start up our program, again, you can see there that we're getting a natural solid color now. Again, do forgive me for the quality of the video there, but looking at it from in real life, we're not seeing any of this flickering pattern. We're just getting nice solid. And again, if we change the test pattern then to individual pixel colors, you can see that we now have our 16 by 16 grid pixel and coming up with quite clear edges there on the actual pixels due to that little divider plate. So everything seems to be working well. Let's go and finish off building the actual unit then. So we need to get this mirrored unit then put into the frame. So I'm going to slide that in. I'm then going to just glue a little bit along the top of surface then, and also then on the inside at the bottom. Obviously I've already threaded through the wires on this, and then I should be able to just simply slide that into place, and those two little strips of glue should then hold it in place. I don't want to put too much glue in there, which would raise the mirror up too far, because then of course the front panel will not slide in over our divider strips. So that should then just press into place, and that is the mirror and all the LEDs now installed into the unit. So the divider grid is next. And really with the markings that we made, you can see that we have the 4 corner points marked there in that black line. So I'm just going to put a blob of glue at each of the 4 corners, just as I'm doing now. So that should then, once I put the divider plate on top of that and line it up, that should really hold it in place. Once of course the whole unit's put together with the top plate on, then things will be fairly static. So just lining that up, just making sure that we get the cancellations all in the right place, making sure that the actual unit is down flat on the mirrored surface. And then just give it a good old press into place. And then I'm just going to simply look through some of the joins where the 2 halves of strips are coming together. Just make sure that I line those up as best as possible. And again, it's not such important, but it's worth just doing a bit of time just to get them right there. So after that, the diffuser panel should just slot into place. So I'm not going to glue this one. This will be removable. So if we do ever need to go back inside here to maybe just readjust some of those divider plates or whatever, we've got that ability to do that. So that just slots into place then. The top of the outer frame, those 2 pieces then just slot into place as well. So again, this will be mounted vertically, so those will not fall out. They'll just sit there, and that gives us access then if we ever do need to get back inside here. We've got it all in place. So that's the overall frame and pixel array in place. We now need just simply to mount up the circuit board. I'm going to be swapping the circuit board out over the next few videos. So at the moment I'm just going to mount it with a couple of foam pads and some glue, and then just stick it really into place. The idea here is that we'll go to some custom PCBs for this, and as I develop the project, the circuit may change a bit. As well as that then, I'm going to leave my connection leads, my flying leads, that bit longer so that they will reach whatever circuit that I'm going to work with. And that then is the unit fully built. So here it is, just standing up vertically as it would normally be if we're going to hang it on a wall or something. And we can run our test programs on here. So all that's left now is to develop the software for the Lightbox, and that's what I'll be covering in the next few videos. We'll be developing a basic framework for the project, and that will handle all the low-level process and display management so that we can more easily build swappable code modules to generate our different animations. We'll also look at using the microphone to listen to music and then analyse the audio waveforms using fast Fourier transforms, and that will let us generate spectrum analyzer screens and displays. Now, as I said earlier, I'm also going to be using this project to show you a few other electronics techniques. And one of those will be how to print your own circuit boards, which we can then compare to some professionally made PCBs from some of the PCB fabricators. I'm also going to be having a look at some of the professional 3D printing services. So if you don't have access to your own 3D printer, you can simply send your files to these and then have them print them for you. So do look out for these upcoming videos and make sure that you subscribe to the channel and turn on your notifications so that you don't miss them. If you like this video, then please do click that like button, and if you have any questions, just leave them in the comments below. So I look forward to seeing you again very soon, and bye for now. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.